Hi students, so I'm going to do this short little video. Actually, it might not be exactly short, but I'm going to be as fast as I can before I'm leaving today because I want to get through some sleep theories and patterns because sleep is, in this chapter of states of consciousness, we're not actually going to have a test, but this is a really important part. When I get back, we'll talk about it a lot. But I want to just start talking about some of the basics of our sleep patterns and what we know about things like our circadian rhythm. So, our circadian rhythm is this kind of internal body clock, this internal clock that happens every 24 hours. We're very much creatures, evolution wise, of light and darkness. And so, when I had you on those 2 days record on your sleep journals, right? When I want you to see kind of varying levels of how sleepy you are, how awake you are during the day, I'm really wanting you to look at your own biological clock. Now, we know our biological clock can be altered by age, by experience, even by hormones and things. You know, if you think about babies spend much of their day sleeping. And as you get older, you spend much of your day sleeping, but it looks a lot different than a baby would. Hormones have a big effect on experience. You know, if you are a shift worker, you have to kind of train your body to work different hours than, say, maybe a teacher who works during the daylight hours. So, our circadian rhythm is kind of this varying amounts of arousal throughout the day. Teenagers, I wanted you to read that article. Your biological clock is really not awake. Most teenagers, their biological clock is kind of turned on, if you will, by about 9 or 10 in the morning. If you see that's when your level of alertness goes up, it's very common because of age. That's when you're awake. Most of you are not awake at 6:30 and 7 in the morning and even 8 o'clock in the morning. Now, if you're a third grader, you're actually like awake at 8 in the morning, but not so much teenagers. So I'm a big proponent of, I'm pretty much a morning person, but I'm a big proponent of later school start times simply because I know it would help teenage brains. So let's talk about these sleep stages. I'm going to move this up here a little bit. So when we talk about these sleep stages, I want you to understand that sleep is a state of consciousness. So like being awake is a state of consciousness, but daydreaming is a state of consciousness. A meditative state is a state of consciousness. So we have many different types of states of consciousness, and sleep is just one of them. It's when we're less aware than when we're during the awake stage. Well, of course, but have you ever been in that, like, tell me if you've done this. Now I wish I was with you right now, but have you ever been like in front of the TV and like watching Netflix or whatever, and you're kind of dozing off, but you're still awake, and so you know what's happening, but you're kind of sleeping? So that these are kind of the stages of our sleep, if you will. This is critical to know. Put this in your notes. You have to know that our sleep stages go in 90-minute cycles, which is why if I ever start talking to you about taking naps, we don't want a nap. Like, we want about a half of a sleep cycle. We don't want anywhere near 90 minutes of a nap because that's getting into an entire sleep cycle, and that's actually probably worse for your body than not sleeping at all. Naps are great. If you can learn the art, master the art of a power nap, that's really, really great. So we don't want to get into too long of napping because we start to get into a sleep cycle, and then our body thinks, oh, we're ready to sleep for 4, 5, 6 cycles, and then you don't, and it's not so great. So if you take a look at, this is an EEG, you're looking at the moment of sleep. So look at those brain waves going up and down and up and down, and then at the moment of sleep, they start changing. Well, you can see how long 1 second is right there. And so this is exactly what we would measure if you were to do something like a sleep study. All right. I don't think there's anything else. Oh, of course, we know that this sleep stage is going to be very much influenced by our hypothalamus in tandem, even with things like our pituitary gland and our, not so much of our adrenals, the pineal gland. The pineal gland is like also deep in our brain. That's in the endocrine system. Also controls our sleep cycles, our wakefulness and sleep. So here we go with the stages. Now I got to move this down here. Sorry. Okay. So our sleep stages, we're first going to talk about REM. And REM stands for rapid eye movement. It's probably the one, if you've heard about sleep stages, it's the one that you've heard about. We talk about REM versus NREM, non-REM or NREM. So an EEG is going to measure these eye movements. The interesting thing about REM especially is that it's rapid eye movement, which means it looks like you're awake on like an EEG, but you're very much asleep. Sometimes we call REM paradoxical sleep. I think that might be on the next page. But this REM movement, rapid eye movement, it looks like you're awake. When you are in REM stage, your muscles get like really tight, they're contracting, your eyelids kind of might like flutter a little bit. That's when you are getting really your best sleep. But we measure stages of sleep in beta, alpha, delta, and theta waves. And we can see them different types of waves here on this next one. So here's beta. These beta waves are when you are like super like alert, like you are firing on all cylinders. So those are beta waves. Alpha waves are actually when you're awake but you're more relaxed. And actually, if you can look at that, like they're more relaxed but you're awake. This is when maybe you're listening in class but you're not necessarily like giving answers or anything. Maybe you're just kind of taking notes more passively. But waking beta would be like when you are doing things and like you are highly awake. There you can see the REM stage. That's what our brain waves would look like during REM stage, which actually looks like we're probably even more awake than we are in alpha. Maybe not quite as much as beta, but you can see that REM stage looks like we're very much awake. NREM 1 and NREM 2, I don't want to get too deep into that. Just know that this is non-REM sleep. And this is when we're looking at stages like delta and theta. And we'll talk about delta here in just a second. Okay, so how are brain waves slow through these stages of sleep? So we start at the sleep onset. Remember when I asked you to do the sleep journals, and I said, well, tell me when you went to bed and then tell me when you fell asleep, because sometimes those are different. And so it comes, right when you fall asleep is what we call the sleep onset. It's the period between wakefulness and sleep. And usually we're talking like a few seconds here. It goes from you were awake and now you're asleep, and it happens really that quickly. So we move into stage 1 and 2, and these theta waves, you should probably write down, theta waves are those really drowsy waves. They're like, let me go back for a second. Like theta waves are probably in like our NREM 1 there, where you're super, super drowsy. It's beyond like really relaxed and like beyond the alpha, way beyond the alpha. So with these theta waves are really starting to slow down. And now I want you to like look at this chart. I want you to learn it, love it, like understand this chart. So take a look at when we're awake and we're getting into that first stage of sleep, right? And this is 0 hours. We're kind of moving down this chart, and we're getting into the second stage of sleep, the third stage of sleep, and the fourth stage of sleep. By the time we get to the third and fourth stage of sleep, this is what we call delta, and delta is deep sleep. This is really good sleep. This is the kind of sleep that when you're sick, you need a lot of. You need a lot of deep sleep. Has your doctor ever told you, like, go home and just go to bed? Like, I'm not going to give you an antibiotic. I'm not going to put you on anything like go home and go to sleep, because that's what you need. It's because that's when we need that delta sleep, when our chemicals are replenished. Not only the chemicals in our brain, but the chemicals in our body too. Also, why babies sleep so much, because they need to process all of the information that they've taken in. They've taken in tons of sensory information that they've never been exposed to as a baby, as an infant, and they got to like process it. And that's when they're doing it in these stages 3 and 4. In REM sleep, okay, now I'm moving back up here. Sorry. In REM sleep, you can see this, our first stage of REM is coming right here, right after, we go in like 90-minute segments, right? So the first stage of REM is coming a little after an hour that we've been sleeping. So we're coming kind of back up into, if you're looking at brain waves, we're coming back up into our different types of brain waves, and we're getting into REM. And now look at REM. REM is like we're awake, right? Look at those brain waves. They're happening so rapidly that our brain is moving so quickly that it almost seems like we're awake. That's why we call it paradoxical sleep. It's like a paradox. It's like we're fully asleep, our best sleep, but we're sleeping. So we're going to go through all of these stages again. We're going to go through 1 through 4 into REM, 1 through 4 into REM. And as you notice, our REM keeps getting longer and longer. We should have, well, there's 5, and that's about right. You should be, as 16, 17, 18-year-olds, for sure getting 5, maybe 6 stages of REM a night, and you can see the REM is going to get longer and longer. This first stage of REM right here, we're only talking a few minutes actually. It's not that long, maybe 6-8 minutes, but as we get longer and longer into our sleep, the next stage of REM is going to be closer to like we're going to be up to about 20 minutes, maybe a little bit more, maybe even closer to 30 minutes, so that you get up at well, like me, I'm going to be getting up at about 4 in the morning to get a flight. I'm going to get up during a REM, and it's going to be really tough on my body. In fact, as we look at the circadian rhythm, we know things like jet lag and time change differences are really, really tough on the body for us to kind of get beyond. So I want to talk about this chart a whole lot more, and I bet you have a ton of questions. So I do kind of hope you jot down some questions. This is vitally important. We need to talk about it some more because there's lots of questions on this that come up through College Board tests, but I'm actually going to stop right there. We'll talk more about REM specifically and about like REM rebound and when dreams and things occur. All right, so I will see you next week. Talk to you later. Bye-bye.